Am I audible? Can you listen to me? So let's start. Today we are going to discuss about cluster computers in this live session. Actually, cluster computers, if you think in technological terms, it will seem something fishy, something hidden from the common users. In our day-to-day lives, all of us somehow get service from cluster computers nowadays. For example, when you use Amazon Web Services or when you use, say, Google Cloud Services, basically behind the scene, what is there is cluster computer. So this particular topic will seem to you too much theoretical. It is because the technological aspects, the algorithms are mostly proprietary. For example, Amazon Web Services. What Amazon uses in their cluster computer services, they will not publish it to the common public. This is their proprietary technology. And if you go to Google Cloud Services, then it might be some other algorithm. And basically the service providers are all competitors. So yes, Microsoft Azure is a cluster computer, right? That is another service. But if you look at the algorithms, what algorithms they implement in their cluster computers uh, are basically not public. It is not written in any book. So if you want to implement cluster computer in the long run, then you have to think about your own technology. Here you will get a theoretical aspect of the entire thing. So today's tutorial will flow like the previous ones. First, we will go through the theory portion, then we will attempt the quiz. If you attempt the quiz, I believe that the theory will be clear to you. And before starting the tutorial, I will ask you to keep a copy and a pen with you so that you can take notes whenever you think necessary. So let's start. Cluster computing architecture actually happened. Let me scroll it up. Goes like this. Here you can see that terminal 1, terminal 2, terminal 3 up to terminal n number of different terminals are connected to one another using some networking technique. However, you should not think of this a ordinary set of computers connected via some network, which we usually see in our college laboratories. Rather, the user will perceive this is server 1, server 2, something like this, and this is uh, public which are accessing this computational system, and user at this end will perceive as if a single unit of computer he or she is accessing, and this is the main feature of this cluster computer architecture. So when you will explore the different facets of this architecture, then the architectural goal or the goal behind this design will be more clear to you. So here are some of the features of cluster computer. Let we go through them one by one. All the connected computers are the same kind of machines. And one thing I will like to add to this point is that they are basically individual standalone machine, or they can act as individual machines. So these different terminals, n number of terminals, which you can see in this diagram, are basically same kind of machines. Next point, they are tightly connected through dedicated network connections. So you can see in the diagram that they are indeed connected with one another, and this connection or networking technology is a salient feature of this cluster computer architecture. And all the computers share a common home directory. That means if you think of the memory of this cluster computer architecture, then you can see that they basically share a common home directory. This directory, the diagram, is being shared by all the n terminals in the cluster computer architecture. So there are different hardware configurations possible, and this hardware configuration difference is based on the selected networking topologies. Now, cluster is categorized as open and closed cluster, wherein open clusters, all the nodes need IPs, and those are accessed only through the internet or web. So you can think of this with an example. Say you are going to use the Google Web Services, or Google Web Services, or more specifically it is termed as Google Cloud Services. So basically what we call or term as cloud, how this is implemented, if you think of this a little bit, you can figure out that in Google's office, what happens, there are basically n number of computers which are dedicated, say, for our Google Drive operations. As they are hosted in cloud, or the interface between you and the Google is what we call cloud computing structure, you have to access the cluster computers which has been hosted by Google using some IP and internet or web. So in this case, basically the cluster computer model is open cluster model. Now, obviously the problem which comes with this is, as you are accessing everything via web, this type of clustering causes enhanced security concerns. This is obvious. Whenever you access something over the web or internet, added security concerns are always there. Now, let me look into closed clustering. In closed clustering, what happens? The nodes are concealed behind the gateway node, and they offer increased protection. That means it is something which you don't actually access through the internet or web. Rather, it is accessed via something called intranet. That means in an office premise, say, all the computers are connected via some networking device to act as a cluster computer, which can be accessed only by the persons who work in that office through the intranetworking which has been implemented into the office. And in that case, we will term it as closed clustering. So Types of clusters. So here you can see different types of clusters which are possible. Let me go through them one by one. Computer clusters are arranged together in such a way so as to support different purpose, from general purpose business needs such as web service support to computation intensive scientific calculations. Nowadays, you can see that different web services are there which we can use in our day-to-day life, such as Google Drive, when we have what we call it spreadsheet operations in Google. Another thing we are using for this particular subject also, Google Classroom, which is nothing but a web service support. So these services are accessible by naive users or common users like us because of this cluster computation. And this is not actually limited to this kind of web service support. This idea can be extended to computational intensive scientific calculations also. A simple example of this is nowadays you can access the what we call it online compilers. So using those online IDs and compilers, you can run your computation extensive scientific programs also. You don't need to run them anymore onto your local computer. You can run them onto the cloud directly. So this is basically the spread of cluster computers. You can see that the spread is basically huge one. There are three types of clusters. They are load balancing cluster. So basically what happens here is that a cluster requires an effective capability for balancing the load among available computers. So in this, what goes is cluster nodes share computational workload so as to enhance the overall performance. For example, a high-performance cluster used for scientific calculation would balance load from different algorithms from the web server cluster, which may just use a round-robin method. This is an example. Don't go for the town by assigning each new request to a different node. This type of cluster is used on forms of web server, web form. So what actually it says is that, again, let we revisit our previous diagram. Here you can see that you have n number of terminals into your cluster computer architecture. Now, just imagine for a moment what will happen if all the load or computational load is put onto the terminal 1 itself. What will happen? So you can think that with extra load, extra load, extra load every second, if put onto this terminal 1, it is going to crash after some time. So what is the solution? Just split the load equally among the different terminals so that there are some kind of load balancing happen here. So this was the idea behind load balancing cluster. So next one is failover cluster. The function of switching applications and data resources over from a failed system to an alternative system in the cluster is referred to as failover cluster. These type of clusters are used to cluster database or critical mission mail, file, and application servers. Why? The question obviously arises here because you can see that when we say database or email or mail server, application server, then the first thing which came to our mind is backup. Say you have a database somewhere. So the question obviously arises in our mind is that what will happen if the machine onto which our database is stored is crashed? What will happen? In that case, you see backup systems become important. So how this goes, like say somehow during its computational life terminal 1 crashed. So the content, whatever is there into terminal 1, will also lost with the crashing. You need a backup mechanism by which when it went off, you can translate everything, whatever was there into terminal 1 to other terminals efficiently. So in this case, this failover clusters become important, which is basically an alternative system for the failed resource. Last one is high availability clusters. These are known as high availability clusters because they offer a, a high probability that all the resources will be in service. If a failure does occur, such a system goes down or a disk volume is lost, then the queries in progress are lost. Any lost query, if retired, will be serviced by different computer in the cluster. This type of cluster is widely used in web, email, news, or FTP servers. Again, these two seem similar, but there is some subtle difference. And where is the difference? The difference is somewhere here. Let me visit our first diagram once again. In failover cluster, you see our main idea was the translation of the content from the failed terminal, say for example terminal 1 to other terminal, right? So you need to translate the contents from failed terminal to other terminals in failed over clusters. But in high availability cluster, the perspective is from the user's standpoint. Say user is here. For example, it is you for the time being, and you are using your Gmail account or Facebook account. Now, the behind the scene content is that your Facebook account is basically hosted somewhere or in some machine into the cluster, right? Say for the time being, your Facebook account is hosted in terminal 1. So what happens is that from remote machine you are accessing your Facebook account through this cluster computer architecture interface. Now when you are accessing your Facebook account, if this machine goes down, what will happen? You see, instantaneously everything will go dark. And from our day-to-day experience of using computers, we know that computers as a whole are failure prone. But just try to recall, since you have started using Facebook, for how many times it has gone dark? Might be never. This is because here somewhere there must be a mechanism by which the content flow is perennial. By perennial I mean it is like a river which flows throughout the year. It never goes dry. So if this machine goes dark or this machine fails, then the content will instantaneously flow from other backup system. And this transition time means from the failure to flow of content from other different machine will not be perceived by the user. And this is the idea behind this high availability cluster. Now you can find the justification of this line. Yes, this one. If a failure does occur, such as a system goes down or a disk volume is lost, then the queries in progress are not lost or lost. Any lost query, if returned, will be serviced by different computer in the cluster. You can see, as we have discussed in our example, if this connection is lost due to the failure of this terminal 1, then your request will be serviced by a different node, that is terminal 1, into the cluster. This was the idea behind high availability clusters. Now let we move to some of the benefits which have been achieved by the introduction of cluster computer architecture into the industry. First one is absolute scalability. It is possible to create a large clusters that beat the power of even the largest standalone machines. A cluster can have dozens of multiprocessor machines. Now, to realize this point, you need some kind of imagination. Just give the idea some thought. How many processors you can embed into a multiprocessor machine? So you will say that I can embed 8 processor octa-core processor, 16 processors, 64 processor architecture. Say 128 cores are there in a single processor. You can think of like this. But they will always be the standalone machines. Now, the cluster computer architecture is always one step ahead of those so-called standalone multiprocessor machines. Why? Because those standalone multiprocessor machines can be included in a cluster computer architecture. Say, your terminal 1 can be a octa-core machine. Your terminal 2 can be a octa-core machine, and so on. Now, extend the idea a bit. Say our terminal 1 is a 128 core processor machine. So You can obviously embed n number of 128 core machines into your cluster computer. So as you increase the number of cores in a single processor, single MIMD processor, the cluster computer architecture in terms of computational capability will always be one step ahead because of this absolute scalability feature. Because each and individual machine can be a high performance MIMD architecture machine, which you can think of. Next, additional scalability. Additional scalability goes like a cluster is configured in such a way that it is possible to add a new system to the cluster in small increments with little cost. Clusters have the ability to add systems horizontally. This means that more computers may be added to the clusters to improve its performance, redundancy, and fault tolerance. The ability for a system to continue working with a malfunctioning node. Give it some thought. Now, you can add an extra terminal to this horizontal architecture, say terminal n+1 with little cost, right? You can obviously think of it. Now, next advantage which this additional scalability point offers you is that the ability for a system to continue working with a malfunctioning node, which we have discussed while we were talking about this load balancing cluster and not load balancing, sorry, failover clusters and high availability clusters. So in fail availability clusters, we had discussed about, say, what will happen to the contents of a particular terminal if it fails. It can be translated to another terminal, and high availability cluster, somehow while terminal 1 is serving the request of user, if it goes off, what will happen? The flow of data or computational task will be done by some other terminal into the network. So this is basically the additional scalability feature which is being offered by this cluster computer architecture. High availability. As we know that each node in a cluster is a standalone computer, the failure of one node does not mean loss of service. It is obvious. From our previous discussions, we know that. You can see what will happen. Just think, if a particular machine goes off, nothing. The entire computational task can be done by using the remaining terminals or remaining nodes into the architecture. So this is basically high availability. The user of this cluster computer service will not be able to understand when a node fails. So a single node can be taken down for maintenance while the rest of the clusters takes on the load of that individual node. This is, in my opinion, is the highest benefit of this cluster computer architecture. You don't need to turn off your entire system for maintenance. As you know, maintenance cost in terms of time, in terms of money, is huge. You don't need to turn off your service, you don't need to disrupt your service for maintenance purpose. Because whatever computational service a particular node is going to offer can be served by other nodes, while you will maintain this terminal 1. Last one is preferable price over performance. Clusters are usually set up to improve performance and availability over single computers. And this point is obvious from whatever we have discussed until now. As you have n number of nodes, multiple number of nodes into your system, obviously performance will be increased. Some instances of performance increase we have uh, observed in terms of high availability and failover. These are obviously this high availability and failover concepts are improvement of performance. So you have improved performance here and availability over yes, and it is obviously going to be cost effective. Why? Because to improve the entire architecture, what you have to do, you have to add some additional nodes to your clusters most of the time. Now you can see that to add some additional nodes, you don't have to do much. When you say you are adding additional nodes, basically what you are doing into your network, you are adding an extra standalone machine. That's all. Nothing more than that. So it is obviously much more cost effective than single computers with respect to comparable speed or availability. You can think of a computer which can give you the performance which is being provided by this cluster computer with n nodes. You can think about the complex circuitry that will be necessary to implement this thing. So with respect to that standalone computer which is capable of which will be capable of providing this much of computational effectiveness, the cost is going to be much lower for this cluster computer. So this was the basic concept behind the cluster computer. So I have a question here. Vishal asked, where is the question? What do you mean by failed system? Right? Let me discuss it a little bit. We all have personal computers, right? So we nowadays what we usually do is rather prefer to store our important data in Google Drive rather than on our personal computers. Why this is so? Just give it some thought. It's because you see computers are failure prone. That means computers over time has some tendency to be broken down. So if you store your important data in your personal computers, when it has gone broken down, along with the computer, all your important data is gone. Now, when you store your data in Google Cloud or Google Drive, then Google also stores the data in some computer at their office. Is it correct? Yes. They store data on their servers. That is essentially some kind of computer. So just think of the same broken down concept here. What will happen to your data if the computer in which Google is storing data, your data has gone broken down. Your data will be lost. But does it happen? It doesn't happen. Why it doesn't happen? Because the data in the failed system, or by failed system, I mean the system which has broken down, is then transferred to some other terminal which is there at Google's office to do the same task for you. And that was the idea behind this failover cluster computers. And next question, what you have asked, I can see is the transition time will be very high or low. Actually, the question is not clear. If I have got you correctly, then you are talking about this high availability clusters where the service is not disrupted to the user end. Say, uh, let me go back to that Facebook example. Your Facebook data, that means whatever you are seeing on your Facebook page is stored at some computer at Facebook's end, right? Let me erase these things. Say for the time being, at this present time, Facebook is serving your account requests from this terminal 1. Now, this is again essentially a computer which can be broken down by some fault. Now, if this machine goes down, what usually should happen is that for that particular time instance, you should be disconnected from your Facebook account. But again, you can observe that this kind of thing usually never occur because some algorithms might have been implemented here. That means here, by here I mean to say on the entire cluster computer architecture, by which when such kind of fault occurs, then this user request, that means when you are accessing your Facebook account, you are constantly making requests to the Facebook server. This user request will be served for that particular time from another terminal, say terminal 2. So in that case, there is some switching between the terminals. That means the task or serving of the request has been uh, transferred from terminal 1 to terminal 2. There is some kind of transition. Now, transition delay will depend on the algorithm which has been implemented into this cluster computer architecture. Now, if you ask about the algorithm, then this algorithm cannot be known by us because, as I have mentioned at the beginning of this session, that these algorithms are proprietary. Most of the time, you cannot know how Google implemented its Google Drive algorithms or how they maintain their Google Drive service. They will never make it public to you. So that was the answer to your second probable question. Now let me move to the quiz. For that, you have to answer. Let me make it public. It is not public yet. Yeah. Just stay with me. Yes, this is the question which you have to attempt. I'm going to share the link into the chat box also. You can alternatively access it from Google Classroom. Assign. Yes, it has been assigned. You can start trying it now. The questions are simple. It is 12:14. We will conclude the quiz session in 10 minutes. So we will conclude the quiz session at it's 12:25. It's 12:15 in my clock. Quiz ends at 12:25. So let's start. You can access the quiz from here. I have shared the Google Classroom link into the chat box, or you can directly access it from here. Be honest, try to do the quiz yourself. Don't get any kind of assistance. What goes on here? It is here. I can monitor it from here. So we have got 3 responses until now. Six. Twelve responses we have got, and 4 more minutes are there. Shovik has written none, sir. So let me wait for others to be finished. So just wait for 3 more minutes. It's 22 responses we have until now. Is there anyone who's not done yet with the quiz? Yes. Is there anyone who's not done yet with the quiz? So 1 more minutes left. So the quiz session as of now is over. I am now toggling off the accepting response button. So hope everyone of you is done. I am releasing the scores. Later on, you can attempt the quiz as many times you like when you will read the material for your own feedback. For now, let me discuss the questions in brief. Before that, I would like to say one thing. Don't forget to write down your university roll number into the chat box for our record, that bloody attendance purpose. Let's start. In cluster computer architecture, many computers are connected over network. Is the answer true or false? The answer is true. And it's because if you can remember the cluster computer architecture block diagram, you can see that a number of nodes which we marked as terminal in this block diagram are connected over the network. Next question. The connected computers in cluster computer architecture execute operations all together, thus creating the impression like a single system or virtual machine. That is again true. When you access Google Drive, you have the illusion that as if Google is hosting its Google Drive service, from a single computer. You never get an impression of something like this. You get an impression that everything is being served from a single computer, and this line was something into the somewhere into the note. Yes, here it is. The connected computers execute operations all together, thus creating the impression like a single system. Third question. In cluster computer architecture, all computers share a common home directory. If you can remember the discussion, you can recall that there was a common home directory for all the nodes, and this common home directory is accessed by the different nodes through the switch equally. So the answer is once again true. In open clusters, all the nodes need IPs, and those are accessed only through the internet or web. The answer is true. And let me tap. Yes. Open clusters are something which are accessed over the internet. That means you need IP address for the nodes. That is obvious. So the answer is true. Next question. Computer clusters are arranged together in such a way so that to support different purpose, from general purpose business needs such as web service support to computation intensive scientific calculation. The answer is true. This answer is true because you don't have to find the answer, you don't have to go back to the study material. You can have an idea of this from your day-to-day life observations. Uh, Web service supports are provided by these cluster computer services such as Microsoft Azure, as someone has mentioned at the beginning of the class, then Google Cloud Services, then computation intensive scientific calculations. This can be run on Amazon Web Services as well as Google Cloud Services. If you know computation intensive scientific calculations, you can run on Google Cloud Services also. So the answer is true. Next question. In load balancing cluster, a cluster requires an effective capability of balancing the load among available computers. So this was basically the definition of load balancing cluster, and it is the very purpose for which load balancing cluster came to existence. A load balancing cluster requires an effective capability for balancing the load among available computers so that not a particular node gets huge load while others are idle. So the idea is to split the computational task equally among the different nodes or different terminals. So you can say that answer is true here. The function of switching applications and data resources over from a failed system to an alternative system in the cluster is achieved by load balancing cluster, failover cluster, cluster data. Again, this is the definition. This actually comes from the definition of failover cluster computers. Failover cluster computers were built for this particular purpose, where when a particular node fails, whatever has been stored inside it were translated or transferred to some other node. So the answer is second option, failover cluster. Devarunde. So you have written your name as Degarunde. Be careful while writing down your name so that your friends don't make laugh of you. Uh, a function of switching applications and data resources. So, yes, we have done this. Next question. High availability clusters offer a high probability that all the resources will be in service. True or false? This is again comes from the definition of high availability cluster. So we have discussed it 2 times during our tutorial that high availability clusters are actually made for this purpose, so that if a failure occurs at a certain node point, the user request can be served by some other node. This example, suppose here is our user and it is making some request, and its request for the time being is served by terminal 1. But due to some unavoidable circumstances, what will happen if this black channel is cut due to the failure of this terminal 1? So user request at that time will be served by some other terminal. So this was the idea behind high availability cluster. If a failure does occur, such a system goes down or risk or is lost, then the queries in progress are lost. Any lost query, if retried, will be serviced by different computer in the cluster. So the answer is true. A cluster can have dozens of multiprocessor machines. So this is obvious from the discussion what we have made until now. Yes, an individual node in a cluster computer architecture can have a high quality MIMD processor for itself. So yes, a cluster can have dozens of multiprocessor machines. The answer is true here. A single node can be taken down for maintenance, while the rest of the clusters take on the load of that individual node if the statement is true or false. So this was one of the main advantage of using cluster computers, which we termed as high availability during our discussion. A single node can be taken down for maintenance. So while you are maintaining some of the nodes of your cluster computer architecture, you don't need to disrupt service, or you don't need to announce to the users that from 10 o'clock in the morning to 3 o'clock in the afternoon, there will be load shedding as we are going to maintain our transformer, something like that. So this was a huge benefit which cluster computer offers. When you maintain a single node, the task this single node is going to perform or usually performs can be serviced by rest of the nodes in the cluster. So again, the answer is true. So we are done. At last, I will like to say you that if you find something difficult during the discussion, then go through the study material, which after a while I'm going to upload into the Google Classroom along with the lecture video. Go through both of them. Once you are done with your study, then attempt the quiz. Once again, I'm making this quiz live for you. It will be there until your semester is over. So, and one thing you must do is, after reading the study material and watching the lecture video, attempt the quiz honestly. From our discussion of the quiz questions, now you know the answers, but don't blindly put tick on them. Reason, try to understand. Then once you are satisfied with yourselves, then only attempt the answer, then only put a tick on the correct answer. In this way, will the mechanism will be able to handle it. Regarding what? Can you type it? I'm waiting for the question. Vishal, if you can listen to me, then please type into the chat box regarding what will the mechanism will be able to handle it. Vishal, can you listen to me? Like if a lot of request is made. Okay, I've got your question. As we have discussed, you see, the main problem with this cluster computer architecture is that it is something which we cannot see in front of our eyes in our day-to-day lives. For example, if you cannot implement this cluster computer thing in your computer lab, in our computer lab, in our college. because the huge cost involved with it. So yes, if a user or if a set of users make a lot of requests to the cluster computer server, then you can observe that it actually doesn't fail. For example, you can think of server of Google or server of Facebook. Millions of users make simultaneous requests at a single second, but it doesn't fail. Somehow it handle it. Now, if you ask about how they handle it, it is their proprietary algorithm which you cannot know, which what is something which they don't make public. So if you want to implement something like this for your industry, say for our college, then you have to develop your own set of algorithms, your own equipments, or you have to choose your own equipments to implement it for yourself. And whatever we have studied today is basically a brief overview only of the cluster computer thing, how they work and what are their purpose. You have the goal in front of your eyes, then to achieve that goal, you have to implement something, and how you will implement that, it is up to you. I think it makes sense to you. Now we are almost near the end of the live session for today. So study it. Hope you have learned something. Have a good day. I am now going to disconnect the live stream. Bye. Have all of you typed down your roll numbers into the chat box? I hope all of you have typed down your roll numbers into the chat box. So have a good day. Once again, bye.